Okay, so let's take our understanding of radicals and do some evaluations. Now again, under the last video we did here, remember what a radical represents, right, is a number, or excuse me, that I can raise a power to get 16. So we're basically reversing a power. And so with that thought in mind, let's go ahead and continue to kind of think through that process. A great way for you to show me your work, right? So, because I know, again, a lot of this can just be done on a calculator. But here we're talking about a square root. I know it's a square root because I don't see an index here, so it's understood that it's 2. So we're talking about a number that I can square to get 121. Hopefully you know your multiplication rule tables really well. That means that this radical represents 11, right? Because 11 times 11 is 121. So so that crazy symbol there, the square root of 121, represents 11. Square root of 9/25. Again, the index is 2. So what number can I raise to the second power and get 9/25? And we're expecting some sort of a fraction out of this because we have a fraction. And if you go back to chapter, what was it, 4.1 and 4.2, we know that we can basically square the top and the bottom. So we actually need two numbers, right? A number upstairs that I can get 9 basically, and another number, how about I just use an at sign, right, to get 25. So what numbers do that? 3 and 5. Again, a quick check. 3/5 times 3/5 is 9/25. So we're, again, trying to reverse the exponential idea of a power. That's what a radical represents. So this crazy radical represents the number 3/5 because 3/5 is the number that I can square to get 9/25. What about the cube root of -8? Well, again, exponential, we're talking about a number that I can raise to the third power and get -8. And I believe that that value is -2. The reason being, if I take -2 and multiply it to itself 3 times, we get 4 and we get -8. So there's -8. What about 1/27? Well, again, we're expecting two numbers, right? So there's a number in the numerator that I can raise it to the third power and I get 1. And there should be another number that I can do to the bottom and get 27. And what numbers are those? 1 and 3 respectively. Again, easy to check. We're just basically saying 1/3 multiplied to itself. So 1 times 1 times 1 is 1. 3 times 3 is 9. Times another 3 is 27. So that symbol represents 1/3. And just on and on. So the next one, we have the 5th root of -1/32. So this one's a little tougher. There's a negative involved. But we know that if I take a number and I multiply it to itself 5 times, we will end up with a negative, right? So the first thing we have is it's negative and negative and negative. So what number can you raise to the 5th power and get 1? Well, that's easy. It's 1. All right. What number can you raise to the 5th power and get 32? Well, if you have thought about that, that's 2. Right? 2 times 2 is 4. Times another 2 is 8. Times another 2 is 16. Times another 2 is 32. So we're looking at -1/2. So that is what your 5th root of -1/32 represents. Getting a little harder. Now I'm going to throw a negative here. And what I kind of want you guys to think about when I say this is we're taking the negative of the square root of 81. And so kind of back to when we were first talking about radicals, right? It's kind of like these cases here, maybe this one specifically, where that 5 is being multiplied to whatever the square root of 11 is. So the idea is if I can find what the square root of 11 is, I take that value and multiply it by 5. The same thing's going on here. Before I can apply that minus or that negative, or that opposite, I got to first figure out what the square root of 81 is. So you can maybe, to really help yourself out, put some parentheses. So what is the square root of 81? I know you guys know that is 9, right? Because 9 times 9 is 81. But now we're being asked to take the negative of it, so the evaluation of this expression would be -9. And that's not because -9 times -9 is 81, right? We're talking about that negative that hang out in front. So be careful about the sequence. That's going to be coming up a lot. We're first evaluating what the square root of 81 is. It's 9. and then we were being asked to negate that value, so I'm going to negate 9. So negative 9 is our final answer there. Here, the negative is inside. So what number can I square and get negative 4? And a lot of students will say that that's 2. Well, we know that 2 squared is 4. And then a lot of students will say, well, what about negative 2? All right, well, negative 2 squared is also 4. So there's our two best candidates, and they both keep giving us positives. As a matter of fact, whenever I square something, I'm always going to get something that's positive. So this is something that is not real. The square root of negative 4 actually does exist in our reality, but we have to expand our number system, and we'll talk more about that in 10.8. For now, in section 10.1, a correct answer would be that's not real. And here's the reason why. There's no number that I can raise to a second power and get a negative out of it, because it's always going to be positive. All right. How about I come over to here? Let's handle the decimals. I have my things out of sequence. This actually makes a lot of sense now. All right, because here what I have is I've got a double negative. All right, and so what happens with that double negative? So again, this negative we have to first apply to what's in this cube root of negative 64. And so the negative 64, what we end up having is what number can I raise to the third power and get negative 64? And if we put our thinking caps on, that number is in fact negative 4. Negative 4 times negative 4 is a 16, times another negative 4 is negative 64. So this number inside here is negative 4. Of course, what are we doing with that number inside? We're applying that negative. So the opposite of negative 4, or a negative times a negative, that guy would evaluate out to a positive 4. So you can already start to see that here we took a cube root and got a value. Here we took a fifth root of a negative and got a value. Here we tried taking a negative square root and we don't. So there's and then here's another cube root of negative and we were just fine. So there's already a little difference between some square roots and third roots with negatives, and we'll investigate that in more detail later in this module. But you can already see there's a little bit of a slight difference. You know what? Let me do another example here. What if I did something like that, right? So I have a negative of the square root of negative 81. And in this case, again, this negative we're going to treat as a multiplication, so I have to figure out first what that is. So what number can I square and get another negative 81? Well, related to this example, this doesn't exist. This is not real. Alrighty, and so since this is not real, it doesn't really matter if I negate it. If you negate something that's not real, you are still not real. So be careful. Double negatives have nothing to do with it. It's all about what is my index and what's my radicand and what's their relation together. So we can either be real like we were in K or not real. So what about decimals? Well, here we're talking about a number that I can square and get 0.25. So recall, to multiply decimals, you multiply like you normally do and move the decimal around. So I need at least 2 decimals here. So we know that 5 times 5 is 25, but I need to account for 4 decimals. So the number we're looking for here is 0.05. Real easy to prove because 5 times 5 is 25. The zeros don't matter. With that 25, there's 4 zeros, so 1, 2, 3, 4, and there's our 0.0025. Of course, yes, you can verify that with a calculator, but you know, I'm showing, I guess, my strength with decimals and fractions without a calculator. This is where you guys have hopefully will eventually be. Last but not least, 0.001. Again, to get 1, we're trying to find a number that I can multiply to itself 3 times to get 0.001. Well, for sure 1, we know that 1 cubed is 1. So to get those decimals, how about we try 0.1? Right? So 0.1 times 0.1. Well, 1 times 1 is 1, and there's 2 decimals. So we get 0.01. If I multiply by 0.1 again, 1 times 1 is 1. There's 3 decimals, 1, 2, 3. And there's our 0.01. So that guy is 0.1. So there's our use. In this case, we evaluated a whole bunch of radicals. And again, I'm still using the idea what it means. We're reversing this concept of a power. And I'm using that to my advantage to find the value of my radical. Lots more to do. We'll see those in some other videos.